everyone, I'm Julia, the chemistry tutor. Today I'm going to talk about the nomenclature of ionic compounds that have non-variable charge metals. So remember, nomenclature is just naming. Ionic compounds have a metal plus a nonmetal, and we're going to talk about the ones that have metals that have a non-variable charge. So let's get started. Okay, so first of all, let's take a look at what your non-variable charge metals are. Okay, I have them here highlighted in their colors. Okay, anything in pink is a +1. So your group 1 is a +1, plus that silver is a +1. And don't forget that you have the ammonium cation that is also a +1, right? Your metals are cations. Okay, so group 2 is +2. Also, the zinc and cadmium over there, those are also +2. And then that group 3 there is your +3. Okay? So just remembering, those are the metals we're talking about right now. Only those groups of metals when we're talking about the non-variable charge metals. Okay, so now we're going to talk about how to go from formula to name. Okay, or from name to formula. Sorry, I have the name written down. We're going to determine what the formula is. Okay, so I have my rules written down over here. Okay, so the first is you just write your formula of your cation and your anion from your name. Okay, so our magnesium we know is Mg because the G came first in the name, and chlorate we know from, remember the saying from the clam in the saying that chlorate has 3 oxygens and a 1 negative charge. Okay, so we write our formulas down. We are not finished. That's only our first step. So the next step is we determine what our charges are on each ion. Okay, so what is the charge on each ion? Okay, when we're looking over here, I've got magnesium. Okay, we know magnesium is a +2 from the periodic table. Okay, chlorate is one of them that follows its charge on the periodic table, and it's a -1. Okay, so we determine what the charges are. You notice I did not write my charges up here because compounds put together equals 0. So we don't write the charges in the actual compound. I put them above my name. Okay, so our last rule is we swap, drop, and reduce. Okay, so what I'm going to do is I'm going to swap and drop those charges. I'm going to bring the 2 to the chlorate and the 1 to the magnesium. That means I have 1 magnesium, which we don't write a 1, and I have 2 chlorates. But remember, I can't just put a 2 there, because if I just put a 2 there, it means I have 32 oxygens. So I have to put polyatomic ions in parentheses when there's multiples of them. Okay, so that's magnesium chlorate. I need 1 magnesium. This charge told me I need 1 magnesium, and this charge told me I need 2 chlorates. Swap and drop. And we don't need to reduce them because they are not divisible by the same number. Okay, it's like if we had a 4 and a 2, we would have to divide by 2 because they are both divisible by 2. But these are both divisible by 1, so they're just what they are. Okay, so let's look at our next one. So our first rule, so we're going to write the formulas for our cation and our anion. So our cation is indium, and indium is in group 3 on the periodic table, is In. And phosphate, we know from Phoenix in our Nick the Camel saying that phosphate has 4 oxygens and a -3 charge. So our phosphate is 4 oxygens. And we know he's a -3. And indium on the periodic table is a +3. So we're going to swap and drop those. The indium gets a 3, the phosphate gets a 3. Well, you might be able to see right now they're both divisible by 3. So we're just going to divide them by 3 and get a 1 and a 1. But I'll go ahead and write them here. I get 3 indiums and 3 phosphates. But then we both divide those by 3. That's our reduce. We swapped, we dropped, and now we reduced, and it's just a 1 and a 1. Okay, so we get rid of all of that. Okay, so there's our formula for indium phosphate. Okay, so now we're going to do the same process, write the formula So we've got calcium is Ca, and hydroxide is one of those that you just got to memorize. It doesn't come from the name. Okay, so I've got Ca for calcium, OH for hydroxide. Okay, I'm going to determine what the charges are. Calcium is group 2, so he's positive 2. And hydroxide you've memorized is a negative 1. So I'm going to swap them. The calcium gets a 1, and the hydroxide gets a 2. Okay, but if I just put a 2 there, that means I have 2 hydrogens. I need 2 hydroxides. Okay, so the hydroxide might throw you off. On the phosphate here, we knew we needed to put parentheses because we were putting a 3 there, and there's a number to clue you in, you need parentheses. But here on hydroxide, there's not a number to clue you in, so you need to remember it's hydroxide, you got to put it in parentheses. Okay, so now I'm going to go to gallium bromide. I'm going to write my formula for my ions. So I've got gallium is Ga. And bromide, remember if it ends in ide, it's just a monoatomic ion, just bromine. Okay, so if we look at our periodic table, gallium is in group 3, he's a positive 3. Bromide, is group 7, he's a negative 1. So I'm going to swap and drop. I get 1 gallium and 3 bromides. Okay, so I put a 3 on my bromide there. I don't need parentheses because it's not polyatomic, it's monoatomic. Okay, I'm going to make that a little bit prettier so it looks good. So I've got a gallium and I need 3 bromides. Okay, so I've got potassium dichromate. So we're going to write our formulas. Potassium is K because it goes kaboom when you put it in water. And then dichromate is the one that has 2 chromiums on it. And if you have 2 chromiums, you need 7 oxygens. Okay, potassium is get rid of some of that. Potassium is a positive 1 on our periodic table. It's group 1. Dichromate, you've memorized, is a negative 2. So I'm going to swap those. I need 2 potassiums and 1 dichromate. So 2 potassiums, and I've got the 1 dichromate. No need to reduce. Okay, now I've got strontium oxalate. So our formula is strontium is Sr. And oxalate is one of your memorizers. It's C2O4. Strontium is group 2 on the periodic table, so he's plus 2. Oxalate is one of your memorizers. You just memorize them. He's negative 2. Okay, you can see they're both the same. They already equal each other out. I just need one of each. But if we brought the 2's down, we would reduce them by dividing by 2 and get one of each. Okay, so now I've got aluminum cyanide. So aluminum is Al, and cyanide is one of your memorizers. He's Cn, right? Cyanide, because he's got the C and the N right there in the name. Aluminum is group 3 on your periodic table. Cyanide is a negative 1. You memorize that. Okay, so I need 1 aluminum and 3 cyanides. Okay, but I can't just put a 3 there because that means 3 nitrogens. So you have to put parentheses on them. Okay, hydroxide and cyanide. Whoops. Hydroxide and cyanide are the 2 that you're going to have to remember you need to put parentheses. If you have like sulfate, there's a number there that clues you in that you need to put parentheses around it. Same with like phosphite. There's a number there that clues you in that you need to put parentheses around it. Okay? These 2 don't have a number to clue you in, so you just have to remember that. Okay? So now on ammonium acetate over here, ammonium we know is the NH4, and we know that he is a plus 1. And acetate is that C2H3O2, and he is a negative 1. So I just need 1 and 1, one of each. No need to reduce. Okay. So now I have sodium phosphite. We know sodium is in A. And from the phoenix in our saying, we know phosphate has 4 oxygens, so phosphite has 3 oxygens. Okay, sodium is group 1 in the periodic table. And we know from that phoenix that phosphite has a -3. So we're going to swap them. Sodium gets a 3, phosphite a 1. So I have 3 sodiums. Okay, I'm going to do one more just because I didn't talk about this earlier. Well, just because I want you to see it. So what if I did ammonium sulfate? Okay, so ammonium being NH4. Sulfate, we know from supper in our saying, sulfate has 4 oxygens. So 4 oxygens and a -2. We know ammonium's +1. So we're going to get 2 ammoniums and 1 sulfate. So I have to put that in parentheses and put a 2 behind it. So even when it's ammonium, the polyatomic ion in the front, if there's multiples, you have to put the parentheses around it. Okay? Now we're going to go the other direction. We're going to go from the formula over to the name. And here's your rules for that. It's really easy. You write the name of the metal, which is your cation, and you write the name of the nonmetal, which is your anion. Okay? So remember, these are non-variable charges. We'll do another video that if you have a variable charge, there is another rule. There's another step that you have to take. Okay, but these are all non-variable charges. They all have a stable charge. They don't change. So we just write the name of the metal, write the name of the anion. That is it. Okay, so here my first one, Mg, is magnesium. ClO3 from clam is chlorate. In is indium. PO4 from phoenix in the saying is phosphate. Oh, by the way, you may notice that right here, when I had them written earlier, I didn't capitalize the second word, but now I'm capitalizing the second word. I am really, really bad about that. You want to check with your instructor to see if they want that second part of the name capitalized or not. I tend to switch back and forth on it. Okay. Okay, so next we've got calcium. Ca is calcium. And OH is hydroxide. Ga is gallium. Br, monoatomic ion, is bromide. K is potassium. Right? And spelling counts. So remember, be sure you're putting 1 T and 2 S's in potassium. And here I've got 2 chromiums in that ion. So that is dichromate. Okay. Sr is strontium. C2O4 is your oxalate ion. Okay. Al is aluminum. Cn is your cyanide. Remember, because it's got a C and an N right there in the name. Okay, this one looks really huge and scary, but recognize your 2 ions here. I've got ammonium, and I've got acetate. Okay, just name our cation, name our anion. Na is sodium. PO3, we know from phoenix that phosphate has 4 oxygens, so my 3 oxygens is phosphite. And now I've got ammonium again. SO4, we know from our supper. Sulfate has 4 oxygens, so that is sulfate. Yeah. And that's it. That's all you do when you're going from formula to name on ionic compounds that do not have a variable charge metal. Just name your metal, name your anion, and you're done. Okay, so that's nomenclature of non-variable charge ionic compounds. So that's all I've got to say about that. Have a great day.